Welcome dear students, we are on the CEC Gurukul lecture and we are discussing the memory card. Now we will discuss how memory cards are made. Ever wondered what RAM is made of and how many is manufactured? Here we will discuss the various steps for preparation of the memory cards. First we define with the part 1, from silicon to the finished wafer, convert the silicon into the wafer. So what we do, memory chips are integrated circuit with the various transistors, resistors and capacitor, and they must be formed on the each chip. So these integrated circuits begin as a silicon which is usually extracted from the sand, and turning silicon into the memory chip is an exacting and it is a great process. Moreover, there is engineering, there is a metallurgy, there is a chemist and the physicist are required. So how we convert the silicon to the finished wafer? Memory is produced in a large facility like it is called a fab, and which contain the many clean room environment. As we talk about the semiconductor industry, so in this semiconductor industry we require the clean room environment. So semiconductor memory chip are manufactured in the clean rooms because the circuitry is so small that even the tiny bits of dust can damage it. So the first process that a clean room are required, it may be number of the 10 clean room, class 10 clean room are required, class 1, class 10 room are required for the preparation of the semiconductor chips like we can say the memory card. So the air inside a clean room is filtered and circulated continuously. So the production team members wear the special caps, gowns and masks with that help keep the air particle free. So the first important point for the construction of the memory card is requirement of the clean room of the class 10 or the class 1, and it must be free from the air particle. So for that the air inside the clean room is filtered and circulated continuously. So first step is the silicon ingots. So first step from the silicon to integrated circuit is the creation of a pure single crystal cylinder or ingot, and that is made of the silicon, and that measure the 330 millimeter in the diameter. After they are formed, silicon ingots are sliced into the thin highly polished wafer less than 6 millimeter of thickness. Means when we got the silicon ingots, then it will be sliced into the thin highly polished wafers, and that wafers are used in the circuit. The circuit elements of the chip, we use the transistor, resistor and the capacitor, are then constructed in layers on these silicon wafer. So circuits are developed, tested by the simulations and perfected on the computer system before they are actually built. So when the design is complete, glass photo masks are made, one mask for each layer of the circuit, and these photo masks are opaque plates with holes or transparencies that allows light to shine through a defined pattern, and these masks are essential to the next step in the manufacturing process, that is the photolithography. Now next step is the photolithography, and in this sterile clean room environment, wafers are exposed to a multi-step photolithography process which is repeated once for each mask required by the circuit. This photography method used for all the different devices. So masks are used to define the different parts of the transistors, capacitor, resistors or connectors that will complete the integrated circuit, and define the circuitry pattern for each layer on which the device is fabricated. So at the beginning of the production process, bare silicon wafer are covered with the thin layer of the glass followed by a nitride layer. So, and this glass layer is formed by exposing the silicon wafer to the oxygen at the temperature of the 900 degree Celsius for an hour or the more, depending on how thick the layers we require. So, on the basis of that, the layer is developed on the silicon wafer, that is a thin layer. That is glass silicon dioxide is formed when the silicon material in the wafer is exposed to the oxygen, and at the high temperature this chemical reaction, that is called the oxidation, occurs at a very fast rate. You see, this is the process, this is the method through which we just do the photolithography, and through this a layer will be developed. Next step is the photoresist. Photoresist wafer is uniformly coated with a thick high sensitive liquid called the photoresist. This is one type of the photoresist, means it resists the photons, resist the light. Portion of the wafers are selected for exposure by carefully aligning a mask between an ultraviolet light source and the wafer. Ultraviolet source will be fall upon a wafer, and this photoresist will just protect the wafer with this ultraviolet light, and in the transparent area of the mask, light passes through it and exposes the photoresist. When the exposed to ultraviolet light, photoresist undergoes a chemical change which allows a developer solution to remove and expose the photoresist and leave an unexposed portion of the wafer. For each mask required by the circuit, the photolithography or the photoresist process is repeat for all the masks. Next step is the etching. This etch step, wet acid or the plasma dry gas is placed on the wafer to remove the portion of the nitride layer that is unprotected by the hardened photoresist. So, this leaves a nitride pattern on the wafer in the exact design of the mask. When the hardened photoresist is removed and it is cleaned with the another chemical, hundreds of memory chips can now be etched into the wafer. Next part is the layering the wafer and completing the circuit. First we prepare the silicon to the wafer, and now layering the wafer and completing the circuit. Now we have a silicon converted wafer, and on this wafer layering will be done and the circuitry will be placed on this wafer. So, manufacturing process, all the circuit element, transistor, resistor, capacitance were constructed during the initial mask operations. So, the next step connect these elements together by creating a set of layer. So, next step is the aluminum layering. Aluminum layering means to being connecting the circuit element together, and insulating layer of the glass is deposited on the wafer, and a compact mask is used to define the contact point window of each of the circuit element. After contact windows are etched, the entire wafer is covered with a thin layer of the aluminum in a sputtering chamber, and when a metal mask is applied to the aluminum layer, the network of the thin metal connections or wires is formed, and that creating a path for the circuit. Next step is the passivation layering. The entire wafer is then covered with the insulating layer of the glass and the silicon nitride to protect it from the contamination during the assembly. So, this protective coating is called the passivation layer. So, a final mask and passivation etch process follows, removing the passivation material from the terminals, which are called the bonding pads. Now, free bonding pads are used to electrically connect the frame to the metal pins on the plastic and ceramic packages, and the integrated circuit is now complete. So, from wafer to integrated circuits are prepared. So, before the wafer is sent to the frame assembly, each integrated circuit on the wafer is tested. So, functional and non-functional chips are identified and mapped into a computer data file. Now, these individual chips are referred to the diamond saw then cuts the wafers into an individual chip. Now, this wafer is just divided into the various individual chips, and non-functional chips are discarded, the rest are ready to assemble. So, these individual chips are referred to as the frame, and before frames are encapsulated, they are mounted to lead the frame, where the thin gold wires connecting the bonding pads on the chip to the frame to create an electric path between the pattern and lead fingers. So, these chips, these various small parts of the electronic gadgets are connected through the gold wire and for the connection. So, you see on the screen that this is how we can put the different type of components, and then all the components connected through the gold wire. That is very thin layer of the gold wire required just to connect the different components on the wafer. Now, we first silicon to the wafer, then from wafer to the integrated circuit. Now, the part third is the frame preparation and the testing. Now, as chip is prepared by the different type of the component and it is attached with the various wire, golden wire. Now, another part is the frame preparation and the testing, how we encapsulate this frame. So we prepare a frame for use in the finished module. For this, we use the next step, that is the encapsulation. So, during the encapsulation, lead frames are placed into the mold plates and heated. Molten plastic material is pressed around each frame to form its individual packages. So, the mold is opened and the lead frames are pressed out and cleaned. Another step is the electroplating. Electroplating is the next step after the encapsulation, where the encapsulated lead frames are charged while submerged in a solution of the tin and the lead. It's like charged while the submerged in the solution of the tin and lead. So, here the tin and lead ions are attracted to the electrically charged lead frame, which creates a plated uniform deposit, increasing the conductivity of the frame and providing the clean surface so that the frame can be mounted. Another step is the trim and form. In the trim and form, lead frame are loaded into the trim and form machine, where the leads are formed and the chips are then served from the frames. Individual chips are put into the anti-static tubes for handling the transportation to the test area for the final testing. Next step is the burn-in testing. Burn-in testing, every chip is tested to see how it performs under the accelerated stress condition. Burn-in testing is a critical component of the module reliability. By testing modules in accelerated stress conditions, we are able to weed out the few modules in every batch that will fail after the minimal use. To conduct burn-in testing, we use the industry leading AMBEX ovens that engineers developed specifically for the burn-in testing. After memory chips pass burn-in testing, they are inspected, they are sealed and ready to assembled. So, next step is the PCB assembly and the construction. As the memory chips are made, they need a way to be connected to the computer motherboard. So, the printed circuit boards solve this problem by providing a way to connect the chips to the motherboard. So, to accomplish this, chip mounted to the printed circuit and final product is finished the memory card. You see on the screen, this is the one type of the memory chip which is mounted on the system. And PCB are built in arrays or the sheets which are made up of the several identical boards. After assembly, the array gets separated into the individual modules, similarly to the how a chocolate bar can be broken into the small squares. So, in this pattern they are attached. By varying the total number of the PCBs in the each array based on the size, Micron maximizes the number of modules made from a given amount of the raw material. Another part after preparation of the chip, another part is the module assembly. And this is the final step which covers the module assembly process, in which the step followed are the screen printing. When the module design is perfected and the PCB produced, memory module assembly begins. This assembly entails an intricate soldering process that attached memory chips to the PCB, and this begins with the screen printing. So, in the screen printing, a stencil is used to screen solder paste onto the finished PCB. So, the solder paste is a tricky substance that holds the chips in place in the PCB. The use of stencil ensures that the solder paste affix only where component chips will be attached. So, the point of attachment are easy to find, and that is the mask on the PCB that determines where the chip need to be placed. Once the solder paste has been applied, automated pick and place assembly machines can scan the fiducial or to the determine where to place the chip on the PCB. Pick and place machines are programmable to know where the chip are placed, where the machine picks the chip and from a feeder and place it on the PCB. It knows exactly where the chip is at. So, chip placement process occurs for all remaining chips and for any other component on the module of the step of manufacturing, and this is the fastest chip placement on the PCB. You see on the screen chips on the various points. Next is the soldering and the attachment. This is the step 13. So in the assembled chip and the boards pass through an oven. Now the heat melts the solder paste into a liquid. When the solder cools, it solidifies, leaving a permanent bond between the memory chip and the PCB. Now the memory chip connected with the PCB. So the surface tension of the molten solder prevents the chip from misaligning during this process. After the chip are attached, array is separated into the individual modules. So, Micron team members usually inspect each module. Many modules also undergo additional inspections using the automated X-rays equipment to ensure that all the joints has been soldered properly. So, all Micron memory modules meet IPC A610 acceptance criteria. The industry standard recognizes the worldwide. Another step is the step 14, which is the post assembly quality testing. Now the chip is prepared, it is encapsulated. Now it is just attached with the PCB. Now the last step where just we test the quality. So Micron Then test the and tag the modules, and then we use the custom equipments to automatically test the performance and the functionality, and this eliminates any possibility of an operator mistakenly placing a failed module in a passing location. So certain modules are programmable with an identifying doc tag that PCB will recognize and read. Next step, which is the last step, which is the shipment. So as it is prepared and all the significant portion of the finished modules are randomly selected for the final quality inspection. So in the shipment, after modules are approved for use, they are placed into the ESD safe plastic trays and the bags, and they are made to deliver. So it is ready to deliver. After extensive manufacturing process, a memory is ready for the use, and it is rigorously testing and approved. Now you see on the screen, this is the one of the memory card, and you are seeing there are number, there are the many signs on the memory card. So what it represent here is that we are having the Extreme Pro 300 megabyte and all that. These we will discuss one by one. This is the one type of the SanDisk memory card. It is having a 6 notation on its card, which is 1 2 3 4 5 6. So what is this one? This is the maximum read speed, and this is the maximum sequential read speed the memory card is capable of in the megabyte and per second. So we can call it, it is having a this much megabyte, 300 megabyte or 200 megabyte speed, sequential read speed, and in this case the maximum read speed of the SD card is 300 megabyte per second. Another is the type of the SD memory card. This two represent the type of memory card. We should also able to locate the proprietary SD card logos on the memory card labels that indicates whether the card is of the SD, SDHC or SDXC type, and in this particular cases the card is of the SDXC. Next is UHS bus speed, that will define the class, and UHS bus speed is also often published directly on the memory card labels, and if it is the UHS card, we can just see the Roman number that is written as the 1. So it is USH2 card, and we can see that the Roman number 2 that card, then the case of the bow card. So next is 4 is the SD speed card, and this number indicates that the SD speed class card, it is per table above. As in the above case, all the modern SD cards should be rated at 10 minimum, which guaranteed minimum sequential write speed of the 10 megabyte. So next, fifth number, which is defined as USH speed class. Aside from the USH bus speed, we can also typically find a USH speed class label, and in the particular example we can see that the speed card is rated at minimum 30 megabyte per second write speed. This is the write speed, and it is U3 level. Another is the memory card capacity, how much capacity a memory card have, that is also mentioned on the HD card, and that the capacity of the memory card is typically displayed in the large number. As can be seen here, this memory card has a total capacity of 128 GB. Compact flash cards is a bit easier when compared to the SD cards. Memory card capacity, now we can see this compact flash card, and it is having a another rotation, just having a 4 notation on it. First is the memory card capacity, which is the typically displayed a large number. As can be seen here, this memory card has a total capacity of 128 GB. Next is the maximum read speed. Here it is mentioned as the 160 megabyte per second. Another is the minimum write speed, which is also mentioned on the tag of the SD card, which is here defined as the write write at least able to write at least 65 megabyte per second. Next is the ultra DMA mode, and most cards will list their ultra DMA mode on the cover, which will give a good indication of its potential. So, particularly CF card from SanDisk has ultra DMA 7 mode, which is why reach top speed of the 160 megabyte per second. So, this is the various type of the card speed defined here, and we define the many type of card and how we can read the data in this memory card. Memory card is one of the compact, portable and data transfer type of device which are used in many electronic appliances, in many electronic circuits, and these memory card having the applications like memory card provide the additional storage to some portable and compact devices. Moreover, they have the application in the electronic gadget, like we can expand the storage, we can do the data transfer through this, we can transfer the file, we can take the backup through this, we can archiving data here, and the different type of memory card used for the industrial and professional purposes. We can use it for the security purposes, we can use it for the medical devices, industrial automation. Moreover, we can use it to store the identity, or sometimes whenever we for the specialized use, means sometimes we use in the camcords, dash cams, and that will just capture the footage from the dash cams, and which provide the valuable evidence whenever it required, it can give the information. Nowadays these drones are used, and these drones use the memory card, GPS devices which can store the data in the portable form, and there are the various devices which use the memory card, like in computer, in laptops, in the smartphones, and moreover in the digital cameras, and in the video preparation we use this type of memory card to store the information and to transfer the information. So, this is a portable storage device which uses the NAND flash memory technology to store and access the data working of the memory card. And moreover, this electronic gadgets are used at the small if we talk about the storage capacity, and if we use a small instrument in the laboratory, we also use this memory card that can store the data or the readings which we are taking manually. We can store it in the digital form, and whenever we require it, we can fetch out that information, we can draw the graph and all that. So, nowadays all the research equipments, all the equipments which we use in the laboratory uses this memory card, so that the data can be transferred from one place to the another place without damaging the instrument, without just just avoiding the viruses and about the corruption, or so that the error free data we can get from this. So, up to now we have discussed the memory devices, in which we discussed the memory card, which is the most important gadget nowadays. Thank you very much.